Hello, দেখতে পাচ্ছ? Can you see it? Oh,
Yes, sir. Visible.
okay, very good. So just a minute. Someone is waiting, I think. Okay, no one. Okay. Actually, my topic is partial differential equation, and there is other part is ordinary differential equation that will take by SD madam, there is Swapna madam. Okay, and other part is, I think we have already that part has been studied by some other people. I think advanced linear algebra. So I think one class already started. Now I start with partial differential equation. Okay, so you can consult some book, any engineering mathematics book, any engineering mathematics book. Okay, any engineering, but there is no other choice. Any engineering mathematics book, you can consult. I think Grewal or something. It says there are so many engineering mathematics books are available, so you can consult. Okay, otherwise you can also consult some Snedden partial differential equation, or you can try Ghosh and Chakraborty differential equation, Rao partial differential equation, SL Ross differential equation, Raisinghanian ordinary and partial differential equation. Also, you can consult these books or any engineering mathematics book. You can find the partial differential equation. So, in your part is very elementary part. Only the some simple solutions of partial differential equations, and I will discuss some methods how to solve this type of differential equation. Anyway, okay. So just you have already known the partial differentiation, isn't it? Hello, we have already known this partial differential equation. Hello, তোমরা কি জানো?
না স্যার, পার্শিয়াল ডিফারেন্সিয়েশন আমাদের ছিল না।
Okay, no problem. Suppose there is a function. Suppose this is, let's write the standard function. This function of m and sigma, which is defined by this. You can see that this function z is a function of two variables. That is, one is variable m, and another variable is sigma. And if we just change only m part, keeping fixed the sigma part, then this function has some effect.
Sir, sorry to interrupt you, sir. Many people are trying to join, sir.
Okay. Now, if we change the variable only one variable, say m, and keep the fixed sigma, then for the change of m, the function that is z, which is function of m and sigma, also affect. Also, if you just kept fixed m, just kept fixed, but vary the sigma part, it also affect the function. In this way, we can find the rate of change only this part. That is, just try to find the rate of change only one variable. That is either m or sigma. So if we just find the change of only one variable, so that is the partial differentiation of the given function. So, for example, suppose we just change the rate of change of only the variable m and kept fixed the sigma part. Then one will get the partial differentiation with respect to m. Similarly, if you just find the rate of change of the only sigma variable and kept fixed only the m part, then one will find the partial differentiation with respect to sigma. We use this symbol. That means partial differentiation with respect to sigma. We just treat m as a constant. But when you find the partial differentiation with respect to m, then you kept fixed the sigma. So in this way, one can easily find the partial differentiation. And not only the first order, you can also find the second order also. That is we use this symbol is like this. So for this differentiation, you just take this an ordinary differentiation, but keep fix the m as a constant. So in this way, one can find several differentiation, first order, second order, third order, and so on. And now, suppose a function t which depends on small t and space coordinates say x, y, and z, and t as time or maybe any other independent variables. And if you find the partial differentiation with respect to t, with respect to x, with respect to y, with respect to z, first order, second order, and third order, and so on, and you find a relationship between the partial differentiation, that relationship is known as the partial differential equation, which is given by this one. That is, if capital F is a function
Sir?
of, yes.
Sir?
Tell.
Sir, we have been taught partial differentiation. You can skip that part.
Yes, sir. Actually,
Yes.
in our second semester, we had partial differentiation in our mathematics courses. So you can skip that part, sir.
Okay,
Sir,
no
skip that
problem.
part.
No
Sir,
problem.
Actually,
you can say one
জিজ্ঞেস
more
করতে
thing.
পার্শিয়াল ডিফারেন্সিয়েশন মানে আমি ভেবেছি যে আপনি ইকুয়েশন গুলোর কথা বলছেন, তো সেটা ছিল না, আমরা ডিফারেন্সিয়েশনটা শিখেছি।
No problem. Okay. Now, an equation involving the partial differentiation. An equation involving the partial differential equation is known as the partial differential equation. It's very easy. Now, if the partial differential equation contains the nth and its lower derivatives, then you say that it is the partial differential equation of nth order. Do you follow it? If a partial equation, if an equation contains the nth derivative and its lower part and lower derivatives, then it is said to be the nth part. The order of this differential is nth order. That is, the differential equation is nth order, and the degree of such equation is the greatest exponent is the highest order. So that means, suppose a differential equation is like this: del x plus del z del y equal to 0. This is definitely a differential equation, and definitely this is a partial differential equation of order 1. Why? Because the maximum order involved in this equation is first order. So this is the first order differential equation. And also degree is 1, because highest power of this partial differentiation is 1. But if you take this one, now this is first order differential equation, but not first degree. First order differential, not first degree. That is a partial differential equation of higher degree. That is non-linear partial differential equation. So in this way we can treat the degree, there's degree 2, but order is first. So in this way we can easily distinguish whether a partial differential equation first order differential or second order differential or third order differential equation, or first degree, second degree, or third degree, etc. It's very easy. And thus we treat the function is a 2 variables only. For this treatment, that is function of 2 variables, we use the symbols. We just remember this symbol. There's p, small p. Small p is nothing but the partial differentiation with respect to s only. You just remember this. Don't worry about it. Just remember these notations. If the differential equation, if a function is function of 2 variables only 2 variables, then one can use the symbol, that is p. So p is nothing but del z del x. Q, that is partial differentiation with respect to y. R, the partial differentiation with respect to x twice. S, the mixed derivative. T, the partial with respect to y twice. So you just use the symbol. So unless you mention others, we just assume P means partial respect to x, Q means partial derivative with respect to y, etc. Okay, you just remember this symbol. This is nothing but symbol. Okay, you just remember this symbol. P, Q, R, S, T. Now, you consider what is the differential equation? P plus Q equal to 0. P plus Q, sorry, P plus Q equal to 1. So that means partial derivative with respect to x plus partial derivative with respect to y equal to 1. That is the first order differential equation. We call it as linear differential equation. But for the second one, that is p square plus q square equal to 1. That means del z del x whole square plus del z del y whole square equal to 1. So definitely this is non-linear. The power of this differentiation more than 1. So up to 1 it is known as linear, and more than 1 it is called as non-linear. You just remember this. Now, how to form a partial differential equation from a given function? Suppose this function is given function z equal to a into x plus y, b into x minus y, ab into t plus c, where x, y, z are independent variables. X, y, z are independent variables, and a, b, and c are the parameters, that is constant parameters. So to form the differential equation, we have to eliminate these parameters, that is a, b, and c. A, b, and c. So just differentiate this function and eliminate a, b, and c. You will get a new equation involving the partial derivatives only. That is, you can able to form the partial differential equation. How? It's very easy. That's first one, differentiate with respect to x, one will get this. Second one, partial differentiate with respect to y, we can get this. Third one, partial derivative with respect to t, one will get this. Now, our task is to eliminate the a, b, and c part. Now, c after the derivative, c has been automatically eliminated. Now, we have to eliminate a, b by using some algebra. How to algebra? How to find the algebra? Because we can easily find this one. Because 4ab equal to a plus b whole square minus a minus b whole square. And we have already found a plus b equal to del z del x. A minus b equal to del z del y. A b equal to del z del t. Just putting the value of a plus b, a minus b, and ab, one will get an equation involving the differentiations. So this is the form of the differential equation from the given function. Okay, so one can easily find any differential equation, or we can easily form the differential equation by eliminating the parameters. Okay, now second one, there's another function, that's y equal to function of x a minus t, another function x a plus t. F and capital F and small f are arbitrary functions. So to form the differential equation, you have to eliminate this f and this f. How? This is very easy. Just differentiate with respect to x first. Again differentiate with respect to y. Clear? One will get this one. Now differentiate with respect to t. Differentiate with respect to t twice. One will get this. Now from this two equation, one can easily eliminate the small f and capital F by using some algebra. What is the equation? This is the equation. That means we are able to find a new differential equation by eliminating the arbitrary function small f and capital F. That means we can able to find or to form a differential equation from the given function. Okay, so in this way we can find several differential equation by several given functions. This is another one. X square by a, y square by b, z square plus z square by c equal to 1. And the parameters are a and b. So you have to eliminate from this equation A, B, and C to find or to form a new differential equation. So you can try yourself. Now, this is a very important part of form a differential equation by this arbitrary given function like this. We can treat this is an example or this is a theorem, whatever you can think it. Now, derive the partial differential equation by eliminating the function phi. You can see very carefully the function phi. What is the function phi? The function phi is given by this one. Function of u and v equal to 0. Where what is u and what is v? And u and v are nothing but the function of x, y, and z. So to form a differential equation, we have to eliminate this one, that is phi. Okay. So we can follow the procedure, because unless we can use this procedure, it is very difficult to eliminate the phi. So this is treat as a problem or a theorem, whatever you think. Okay. Now, as previous, we just use a notation, that is del z del s equal to p, del z del y equal to q, and we have write this one, that is del y del x equal to 0. Why? Anyone? Why del y del x equal to 0 and del x del y equal to 0?
X, Y are independent variable.
Good, very good, very good, very good. This x, y are independent, so they fit these two terms 0. Now you see that. Now differentiate and phi. This is this phi. This differentiate with phi with respect to x. Okay. What we find this one. Anyone? You can try to say how this equation comes. Anyone? Hello, anyone?
Chain rule
Exact. Just use the chain rule. I just mentioned this one. This is the chain rule. This is nothing but a chain rule. This one, the chain rule. Okay, you can use the chain rule. So by using the chain rule, one can easily find this one. And we have used this one, del z del equal to p, del z del y equal to q, and this equal to 0. So one can easily find this one. One can easily find this one. There is p and that is in terms of p. So just taking the one side del phi del u by del phi del v, one will get this one. It's very easy. Similarly, if we differentiate with respect to y, differentiate is phi with respect to y. So one can easily find similar way in a similar way this one. Okay. Now please see the page 3. Oh, this part is this one. Okay. Can you see it? This is easy, quite easy. Okay, no problem. So from this equation, this one equation to 2, and this equation you call it as say 3. Okay. So from 1 and so from 2 and 3, one can easily find this one by eliminating del v del u, sorry, del phi del u by del phi del v. Just eliminate one, you get this one. And if you just rearrange, one will find p with coefficient capital Q, small q with coefficient capital Q, and r. What is r and what is p and what is q? And p is nothing but this one. This one, and r is nothing but this one. But this expression is nothing but the Jacobian. This is called Jacobian. Do you know Jacobian? Jacobian. We have
Yes, sir. Yes, sir.
Okay, good, no problem. Good, very good. This is this we are use this symbol as Jacobian. Okay, so if p, q, and r is the form of Jacobian. Okay. Now this form, the equation is called as Lagrange linear equation. That is this is our equation. This is our equation by eliminating phi. By eliminating phi, this is our equation. Okay. So in this way, one can easily construct from any given function, given arbitrary function, by eliminating that arbitrary function to form a partial differential equation. So someone is waiting, I think. Okay. Okay. Now take the problem like this. Form a differential equation from this one. Okay. We just compare this one is in our previous one, phi is u and v equal to 0. Okay, just compare the previous one. Just compare the previous one. Compare the previous one. This one. Okay, phi is function of u and v. Luckily, the u and v is given by this one. This is our u and this is our v, and that means this is a function of phi is a function of u and v are given by this formula, by this expression. So our task is to find the to form the partial differential equation. One can use directly this formula. Okay, we can use directly this formula, where capital P, capital Q, R, capital R is given by this one. One can use directly this formula, or you just derive yourself. Okay, we just derive yourself. So in this case, we just derive this, and that partial with respect to x. Use the chain rule. Similarly, partial with respect to y. One by using the chain rule, one can get this, and by eliminating this one, ultimate we get the partial differential equation. So two ways: either you can use directly the formula, or you can derive yourself. Okay, so this type of problem will come in the same. This is another example, and so on. Okay. Now, how to this up to this, we just form the differential equation. But now the task is how to solve this differential equation. So actually there are two parts. One is we have to construct the partial differential equation, and second part is you have to solve that differential equation. How to solve this differential equation? So at first your syllabus in your first order differential equation and second order differential equation, but definitely degree is just one, that is linear first order differential equation or linear second order equation, and so on. So in your syllabus only the linear first order, second order, and third order, not first degree, sorry, not second degree, third degree, or others one. So at first we start with the first order linear partial differential equation and first order linear partial differential equation. And to solve the first order partial differential equation, we use the theorem or formula given by Lagrange. So Lagrange proposed this formula or theorem to solve the partial differential equation. So I will proceed how to use or how to solve the partial differential equation by using a Lagrange formula or Lagrange theorem. So theorem states that suppose this is a given partial differential equation. This is linear first order partial differential equation. Okay, where capital P, capital Q, and capital R are the function of x, y, and z. You have already known what is small p. Small p is nothing but del how much? Del z, del x, or the dependent variable del u has the dependent variable u. So del u, del x, and small q is partial derivative with respect to y, that is del z, del y. But in this case, you use the term u, so here del u, del y. We just remember the symbol small p and small q. Okay. Now, for the differential equation, if these are the solutions, that is u equal to constant and v equal to constant be the solutions, then their solutions are the solutions of the ordinary differential equations. I just repeat, Suppose the given partial differential equation, u and v are the solution, then that solution is nothing but the solution of the ordinary differential equation. How to form the ordinary differential equation? This is very easy. Del x by p, that is the coefficient of small p. Del y by capital Q, that is coefficient of small q. And del z by capital R, that is the right hand side term. Clear? So from the given differential equation, one can easily write down the equation, because the solution of this differential equation are the solution of this ordinary differential equation. Now the solution of the partial differential equation are the solution of the ordinary differential equation. And how to solve the ordinary differential equation? We have already known how to solve the ordinary differential equation. So Lagrange gave a huge amount of simplification to solve the partial differential equation by using the ordinary differential equation. So it's tremendous. He did a tremendous work. Okay. Now to prove it. How to prove this type of equation? That means the solution of this equation, partial differential equation, are the solution of this equation. This equation is known as subsidiary equation. This equation is known as subsidiary equation. Just remember the term subsidiary equations. Okay. Now how to solve this? How to prove it? Now very carefully. Suppose these are the solutions. Okay. If these are the solutions, their solutions should satisfy this equation as well as this equation. Any problem? Because we have mentioned that the solution of this equation follows both the equation. So this equation should satisfy this equation. This solution should satisfy this equation also. That is, this equation satisfy the partial. This solution should satisfy also the ordinary differential equation. This is a given theorem. How to prove it? The proof is very simple. Suppose u equal to a. This is a given solution. Okay, u is a function of x and y and z. So what is del u? Del u equal, right hand a equal to constant, or equal to this equal to 0. Now what is du? We have to use the chain rule. This is the chain rule. Any objection? Do you follow? বুঝতে পেরেছো?
sir.
Okay, good. Similarly, v equal to constant. So del v equal to this 0, because v equal to constant. Right hand side is a constant. So dv equal to 0. Okay. Now what is dv? We have to use the chain rule. This is the chain rule. Very simple form. Okay. Now solve this equation by using your class 9 level or 10 level knowledge. How to solve this equation? Do you follow? Anyone? How to solve this equation? Cross multiplication rule.
হ্যাঁ স্যার, আমি ডিটারমাইন করলে হয়ে যাবে।
Exact. Best using your class 9 or 10 level knowledge. No
Yes,
problem. Okay. So this is the solution. We call it as 5. Now compare 3 and 5. What is 3? This is 3, equation 3. Now this is equation 3. Okay. And 5 is this equation 5. Okay. Now compare 3 and 5. One will get. Any objection? Because dx by this one, dy by this one, dz by this one, dx by p, dy by q, and just compare dz by r. So you just compare, one will get this one. Okay, very simple. We call it as 6. Now differentiate with respect to there is a 4. What is 4? Now this is a given equation. This is the solution of this equation. So differentiate with respect to x and y. One can use the chain rule for x. One can use the chain rule for with respect to y. This is respect to x and this is respect to y. Okay, one can use the chain rule. Now take one side, this one. By eliminating, we have already mentioned in the first theorem or first example, by eliminating del f del u del f del v, one can get this one. Clear? But we have already found this one, p by this one, q by this one, r by this one. So by eliminating this Jacobian, one will get this one. So the solution satisfies this equation. So that means one can easily use any first order partial differential equation for its solution to write the auxiliary equation or subsidiary equation and solve the ordinary differential equation. Okay, let us take some examples. So remember this theorem. Some examples, repeat one, this one. Look at it. This is very easy to, I think, but we just try to look it very carefully. Suppose this is a differential equation. P, capital P, small p, capital Q, small q, and r. Where P is with respect to x, Q with respect to y, and PQ are the function of x and y and z. Okay. Now to solve the equation, we have to form first we form the subsidiary equation from the given equation. From the given equation, we use the subsidiary equation and try to solve the simultaneous this equation. These are the solution, and write down the solution as the function of arbitrary variables, that is function of u and v. This is the original solution of the partial differential equation. So you just use these 3 steps to solve the partial differential equation by using the Lagrange method. Now let's take a particular example. Now the P, Q, and right hand side term. So what will be the subsidiary equation? Dx by coefficient of small p. What is the coefficient of a small p? Anyone? What is the coefficient of a small p?
1, sir.
1. So there I just 1. Dy, that is the coefficient of q. Coefficient of q. What is the coefficient of q? 2 z to the power 1/3.
2 into j to the power 1 by
1/3. 1 3. Okay. And dz by right hand side term. What is the right hand side term? It is 3 into z to the power 2/3. So this is the subsidiary equation. Okay. Now from the given equation, you can easily form the corresponding subsidiary equation. Okay. Now one part is complete. Now we have to solve this one. How to solve? Take 2 at a time. Take 2 at a time. Whatever you can use first or second or third, or also you can use the algebra. Whatever. We just take the equations 2 at a time and solve it. Now the second and third equation gives. Now we just use this second and third. Second and third. Second and third. Okay. We can use second and third. So one can easily find dy, the left hand side dy and right hand side dz by function of z only. So one can easily solve this one. We call it as constant as b. And first and last. First and last. Okay, one can easily solve. The solution is x minus z to the 1/3 equal to b. So the corresponding solution is function of a and b. The solution is function of, these are solution a and b. Phi is arbitrary equation, arbitrary function. So what is a? A equal to this one. I write this one. What is b? We write this one as b. So this is the solution. Very simple. Very simple to solve the partial differential equation. Any objection or any doubt?
স্যার মানে একটা কোয়েশ্চেনে ধরুন মানে ওটা কি সলভেবল না হয় দেন ওটা কি করব?
You have to use some algebra to solve this equation. Okay, I will help proceed one by one. Okay.
We are not getting the exact function, right?
No, not exact. This function should be arbitrary. This function should be arbitrary.
So if I need the exact function,
then you need to boundary condition. That is another portion of partial differential equation.
okay.
It is not your syllabus only. That is the honors syllabus or master's syllabus like this. Okay. So at first we have to find the solution, general solution. This is called a general solution. And you will just find a particular solution by using the arbitrary boundary condition to get the particular solution. Okay, that will be a new chapter or new portion of this partial differential equation. That is a separate part, separate part. Okay, but in your syllabus only how to find the general solution. Okay, but if you are interested, then you can follow the partial differential equation by Rao, the book of Rao, R-A-O, Rao. The name of the book is Partial Differential Equation. You can follow. Okay, this book is available in the market. So I think I have a soft copy. Okay, well, I will search. If I have, then I will provide you. Clear?
Okay, sir.
Okay. Now that's another problem. Y square plus z square minus x square into p, 2xy q, 2zx equal to 0. Now at first we have to find we have to write the subsidiary equation. So what is the subsidiary equation? Dx by something equal to dy by something equal to dz by something. What is dx by something? Dx means the coefficient of p. The coefficient of p. So I just outdone this one. Dx by coefficient of q. So we just write down dy by this one. And right hand side term is the dz by this one. So right hand side term is, because it is the left hand side plus 2zx. So just take it as right hand side. So minus 2zx. So I write minus 2zx. Okay. Now how to solve this equation? You can see that we can solve these two equations. Okay. But it's very difficult to solve the other equation, that is using this one. But we just a trick. We just use a very simple trick. Okay. Now take the last two equations. Last two terms one can easily solve. This one, y by z equal to c. It is clear? Now we use the trick like this. Do you know addition and division rule? Hello? Jogba Pokya Jano, do you know?
Yes, sir. Yes, sir.
Okay, very good, very good. Now I just use the algebra like this. From this equation, we just multiply 2x. There is no definite rule, but you have to use your intuition only, okay, to find the solution of this equation. There is no exact rule. Now we just use a 2x multiply, we just multiply 2x, okay, multiply 2y, 2z by 2z, no problem. Now using the addition and division rule. Okay, because is a by b equal to c by d. So this equal to a plus c by b plus c. We can know, I think you have already known this one. Okay. So from this equation, we take the last two equations, these equations and these equations. Okay. We can use this equation. Now we can easily solve, because this just takes 2x common. Now this is d of x square, because 2x x square, 2y square dy, 2z dz, that means d of x square, the first term. Similarly for second term, d of y square, and so on. So I have just added this one. Okay, and denominator is x square plus y square by z square. So one can easily solve. Take the x cancel out, take z left hand side and right hand side. The element is x square plus y square plus z square by this one. So one can easily solve this equation. Okay, so ultimately these are the solutions. So in this way, you just use your some algebra to solve the differential equation. So there are so many problems I have given. I have this one. This is another problem. This is another problem. I just give some hints. This is another problem. This is another problem. Another problem, and so on. So you just practice yourself, and you can consult some problems from any books and try to solve. And if you have any problem, you just post in the WhatsApp group, and I will try to solve this equation. That's problem. Okay, and I will provide these lecture notes to you.
Sir, will you say once again the linear or nonlinear equation?
Okay. Suppose what is P? probability model is P equal to del Z del X. Okay, what is Q? We just remember this is a symbol. Okay, del Z del Y. So if a equation containing the first power of P and Q, first power of P and Q, first power of, okay, this is called a linear. And for other power, that is say P square, say Q cube equal to 1. So this is a non-linear term. The equation, where the partial differential equation maximum power is 1, this is called linear, and the power is more than 1. The differentiation part, the differentiation of any involving the equation more than 1, we call it non-linear. It's very simple. Do you follow? বুঝতে পেরেছো?
ওকে স্যার, বুঝতে পেরেছি।
Good, very good. So I just provide this.
লিনিয়ার ইকুয়েশন কি সলভ করা যায় না?
Very difficult to solve. যাবে কিন্তু but it's very difficult. You have to know several methods, or you have to do some approximate solution, or you have to know the boundary conditions and so on. So
নেভিয়ার-স্টোকসটা এখনো সলভ করা যায়নি।
হ্যাঁ,
এই পার্টিকুলার রিজনের জন্য তো স্যার নেভিয়ার-স্টোকসটা এখনো সলভ করা যায়নি।
Exactly. So there are so many differential equations still. But there is the new exact and open problem. So you can use the GTR. GTR means general theory of relativity, Einstein theory. That equations are highly nonlinear differential equations. Navier-Stokes fluid dynamics is very highly nonlinear differential equations, and so on. There are so many equations. I think Dirac equation, and so many equations in physics or chemistry or where others part. So actually, the nature contains nonlinear differential equations. So to find the exact nature or exact situation, physical situation, we have to know how to solve this type of nonlinear differential equations. So very difficult and very big chapters to solve the nonlinear differential equation. Also, partial differential is very very attractive to the physicists, chemists, biologists, and so on, and also mathematicians also definitely. So for your engineering field, you have to face several differential equation which is nonlinear or linear or ordinary or partial to find your type of problems. That means to construct, suppose you construct a bridge, to construct a car, to construct, and so many defined things in engineering field. So there are so many equations are coming which are very highly nonlinear. So you have to know, at first you have to know the linear, then you have to know how to solve the nonlinear differential equations. Okay.
স্যার একটা কোশ্চেন ছিল, মানে এই রিলেটেড নয়েস একটু করতে পারি?
হ্যাঁ, শিওর।
স্যার মানে আমি ইলিপ্টিক্যাল ইন্টিগ্রাল গুলো করছিলাম, মানে ওগুলা যদি স্যার আমাকে এমনি ভ্যালু বার করতে বললে তো পারবো, সিরিজ দিয়ে করে দাও, মানে সিরিজটা ভাঙতে হবে ম্যাকলোরেনটা। মানে আমি বলছি যদি আমার এক্সাক্ট ফাংশনটা চাই কোনো কারণে, তখন মানে ওটা করা যাবে না?
খুব ডিফিকাল্ট, ইটস ভেরি ডিফিকাল্ট।
কারণ স্যার মানে একটা বই আমি করছিলাম, ওখানে ওরা করেছে মানে আগে মানে বার করেছে কার্ভের ইকুয়েশনটা, তারপরে সেটাকে মানে কার্ভেজারটা বার করে যায়, বুঝতে পারছেন তো, ওরকম তো আছে ওইটা। তাহলে কিন্তু ফাংশনটা দিয়েছে ওরকম ইলিপ্টিক্যাল ইন্টিগ্রেশন, তাহলে ওটা তো করাই যাচ্ছে না স্যার। মানে
না, ওগুলো করা ডিফিকাল্ট, খুবই ডিফিকাল্ট। আমি একটা বলছি তোমাকে, দেখো, if a function is continuous function, this is arbitrary function, okay? Do you follow? বুঝতে পারছো?
হ্যাঁ স্যার, বুঝতে পারছি। মানে তখন মানে
আমি যেটা বলছি শুনো, জাস্ট ক্যালকুলেশন, তো I think you can find the answer. A function which is continuous or piecewise continuous, okay, and bounded and some restricted properties, then we can always find a polynomial function of x. Do you know polynomial functions? That is x square, x cube, etc.
Yes.
And these two functions is less than epsilon. Do you know for the time epsilon? Epsilon is very small quantity. That is the difference between two functions is very small. So we can always find a polynomial function where difference is very small. In other way, we can treat this function f converts to this function as n tends to infinity. That means we can always get a function which is polynomial function, that function equivalent to a continuous function. That means your solution is polynomial function, there is a series solution, okay? So that series solution should convert some specific function, say a specific function h, okay? Now tell your question.
বুঝতে পেরেছি। না মানে আমি বলছিলাম যে ওটা মানে সেই রেডিয়াস অফ কার্ভেচারটা বার করে ওটা উল্টে দিলেও তো হয়ে যাবে মানে ওইটার ক্ষেত্রে, কিন্তু
That is a particular case.
হ্যাঁ
But
পার্টিকুলার
in general,
in general তে আমি জানতে
you
চাইছিলাম।
can't, you can't. পারবে না। Okay. So I have to stop here and I will provide the lecture notes in your group. Okay.
Thank you, sir.
Okay. Now you can leave. Thank you.
Okay, sir. Thank you, sir.